You wake up in a mini-mathematical universe. These are inspired by Robert Abbott and Sid Saxon. In the mini-mathematical universe, you get to do one of two things every turn. You can either poke and I will tell you the answer. For example, here I'm telling you the answer is 2. Here I'm telling you the answer is 4. And here I'm telling you the answer is 8. At the start of each of these mini-mathematical universes, you definitely want to poke because you don't know what's going on. But then you can choose the second option. Once you think you're starting to understand, you can choose to guess. If you guess correctly, you get +1 point for your class. If you guess incorrectly, you lose a point. So you might want to choose to guess the structure of D. Or you can poke at D. I'll tell you the answer one way or the other. Here you go. So you'll either have 1 point, or if you guess the structure incorrectly, you will have lost a point for your classroom, or you'll be at 0 points because you just poked, and I'll tell you the answer. No matter what way you pursue it, you definitely want to take a break every so often and look for observations that kids have and hypotheses. So Anna has observed that there's 1, 3, 5, and 7 circles so far. Perhaps that is a good observation to make. Ben's hypothesis: the number of circles is odd. Carl's hypothesis: the number of circles will increase. Dan's observation: the bottom numbers are 2s. So these are all great hypotheses and observations. You want to have at least as many wrong ones as right ones. We totally underestimate the joy of getting wrong hypotheses. Okay, let's continue. 16 is the number. Who wants to guess or who wants to poke at E? So if you want to, I'm going to now tell you the answer one way or the other. Here it is. That is the structure of E. And the number, if you want to poke or you want to guess, go ahead. And here's the answer. There. 20. Probably not. Like many people at this point were thinking 2, 4, 8, 16, 32, right? Okay, let's go on. So from now on, I'm going to not speak. Except to say we're going to do F. There's the structure. There's the number. G. There's the structure. There's the number. H. Structure. Number. I. Structure. Number. So you can pause the video at any time to allow your students the chance to guess or to poke. J. Structure. Number. K. Structure. Number. L. Structure. Number. M. Structure. Number. N. Structure. Number. O. Structure. Number. P. Structure. Number. Okay, what's going on here? So there are, first of all, this is prime factorization. You're dealing with prime factorization trees. But what's the structure here? Well, the first thing that you should notice is that whenever you split two numbers in, so let's say you're splitting 200, it's 10 times 20. Whenever you're doing that split, you have to make the split as equal as possible. So for example, 200 is not 2 times 100, it is 10 times 20. So it's as close to equal as possible. The second thing that you should notice is that if one of those two factors is larger, the larger one goes on the right always. So it's not 20 times 10, it's 10 times 20 is equal to 200. And underneath 20, you'll notice that it's 4 times 5, not 5 times 4. So that results in a unique prime factorization tree for every integer. Now, how do you choose each of these integers? For example, why do we not see the number 144? The reason we don't see all of the integers is that we are only highlighting those structures as they first appear. So the first time that 64 appears, that structure with 64, the first time that happens is with the number 64. Yes, it also happens with the number 144, but we only look at the first time it occurs. So, for example, 28. Well, 28 would have the same structure as 20. So that's why we don't see 28. You could imagine that 28 is there. It's just hidden by the number 20. It's behind the number 20. Okay, so those are, I'm calling that my integral fission. And I really like this. I'll now show you some more of them. So here are the numbers up to 1152. This allows you to come up with a whole bunch of puzzles. This isn't just about doing mini mathematical universes and getting your students to guess. Once they guess this, it allows you to do so much. So, for example, let's look at this here. This is the first time that these prime numbers first appear. So we get the 2, the 5, then we get the 3, then we get an 11, and we don't get a 7 for a while. I think it's not until 336 that we get a 7. So yeah, lots of beautiful, beautiful ideas here. Here's another one. So what is the first time that 3 consecutive integers have this shape? And I'll give you a clue right now. It happens between 150 and 200. Okay, go ahead and try to figure it out. And here is the answer. The first time is 170, 171, and 172. What is the first time that this shape appears 3 times? Now, this is a lot harder, like a lot harder. And I'll give you a clue. It happens between 1800 and 1900. Are you ready? Here it is. 1885, 1886, and 1887 is the first time that shape appears 3 times with consecutive integers. Okay, here's another question for your class. I have got the same shape on the left and on the right, but I am giving you 2 of the numbers each time. I'm giving you a 3 and a 7 on the left and a 3 and an 11 on the right. The question is, which of these shapes has got more integers? So how many integers can you have, or is it possible for any integer to have that shape and to have the 7 and the 3 in those positions? How many different integers are there? How many different integers are there with that shape and an 11 and a 3 in those positions? So which one's more? So first of all, you can take a guess which one you think is more. So your class can, before they do any calculations, they can guess which one do they think is going to win. Okay, now I'm going to show you the answer. The answer for the 7 and 3 is that there are 5 different numbers that have the 7 and the 3 in that position. Okay, and for the 11 and 3, there are also 5 different numbers. So this was a trick question. It's a tie. So there's also 5 different numbers that have the 11 and 3.